Okay, so let's say that you were in a bumper car, and the bumper car has a mass, including you, of 130 kilograms, and you're originally going 3.1 meters per second, and you're going to run into a wall. And we know that you are going to bounce back. So we're going to put that as our final. You're going to bounce back going 2.3 meters per second. Now you have to be very careful because moving forward is this direction. Let's call that positive. Once you hit the wall, you're going, oh, I'm moving the whole thing. Once you hit the wall, you are going to be coming backward. So in other words, you're going to come back moving in the negative direction. So this is going to be a negative 2.3. That is the number one mistake that people have with bounce problems. If you can just remember that when it bounces back, the velocity is negative, you're really going to have an easy time with the rest of it. So momentum is equal to mass times velocity. So momentum is equal to our mass is 130 and our velocity was 3.1 originally. So our original the original momentum is going to be 403 kilogram meter per second. What is your final momentum going to be? Your P final is equal to mass times your velocity final. So your P final is going to be 130 times negative 2.3. So your P final is going to be negative 299 kilograms meter per second. So what does that mean for our change in momentum? Well, change in momentum is equal to P final minus P initial. So our change in momentum is going to be equal to, well, final, don't drop the negative, you got to keep that in there, negative 299 minus 403, because that was our initial, there's our final. So our change in momentum is going to be negative 702 kilogram meter per second. And the next question is, what is your impulse? The number one thing people forget is that impulse is equal to your change in momentum. So if you know one, you know the other. So that's negative 702 kilogram meter per second. And if the impact lasted for 0.4 seconds, what would be the force on your body? Well, the only equation that ties time, which is in seconds, and force together is impulse is equal to force times time. So impulse is equal to, we know our impulse, so we can actually put that in. Our impulse is negative 702 equals our force, which we don't know, and our time is 0.4. Right? Yes. So we're going to divide by that 0.4, and we get a force of negative 1755 newtons, which is quite a jolt there.